Welcome back to another episode of Everyday Nuggets. In our modern world, soap is something we use daily without much thought. It's a fundamental part of our hygiene routine that keeps us clean and healthy. But have you ever wondered what exactly soap is and how it's made? Today, we're diving into the fascinating world of soap making, a process that combines chemistry, history, and artistry. Soap may seem simple, but it's actually a remarkable substance with fascinating molecular properties. At its core, soap is a salt of fatty acids produced through a chemical reaction called saponification. This reaction occurs when fats, or oils, which contain triglycerides, interact with a strong alkaline solution, typically sodium hydroxide or potassium hydroxide. The magic happens when these components mix together. The triglycerides break down into glycerin and fatty acid salts, what we call soap. These soap molecules possess a unique dual personality. One end is hydrophilic, water-loving. In contrast, the other end is hydrophobic, water-repelling and oil-attracting. This special structure creates the perfect cleaning mechanism. Think about when you wash your hands. The hydrophobic ends of soap molecules eagerly attach to oils and dirt on your skin, while the hydrophilic ends bond with water. As you rinse, the soap molecules form tiny spherical structures called micelles that trap the dirt and oils, which are then rinsed away with water. It's like having microscopic cleaning agents that grab onto grime and make it rinsable. Without this chemical structure, water alone would struggle to remove oily substances from your skin. A beautiful dance of chemistry happening right in your bathroom sink. This molecular design is what transforms ordinary water into an effective cleaning solution, making soap one of the most essential chemical innovations in human hygiene history. The creation of soap isn't a modern invention. Humans have been making soap for thousands of years. Archaeological evidence suggests that soap-like materials were being produced as far back as 2800 BCE in ancient Babylon. Clay cylinders containing a soap-like substance were discovered with inscriptions describing mixing fats with ashes, an early form of the saponification process we still use today. The ancient Egyptians combined animal fats with vegetable oils and alkaline salts to create a soap-like substance for treating skin diseases and washing. Meanwhile, the Romans learned about soap from the Celts, who made it from animal fat and plant ashes, and they took soap making to new heights, even establishing soap factories. During the Middle Ages, soap making became an established craft in Europe, with centers of production in Spain, Italy, and France. Marseille emerged as a major soap-making center in the 13th century and became France's leading soap manufacturer in the 17th century. By then, there were multiple factories producing soap in Marseille, although widespread personal use came later. The Industrial Revolution transformed soap making from a craft to a science. In 1791, French chemist Nicolas Leblanc developed a process for making soda ash from common salt, which provided a crucial ingredient for soap production. Later, in 1823, French chemist Michel-Eugène Chevreul discovered the chemical nature of fats, oils, and the saponification process, bringing scientific understanding to soap making. Let's explore how soap has been crafted through the ages. Traditional soap making involves several distinct methods, each with its own characteristics and advantages. The most popular traditional approach is the cold process method. This begins with a precise science, carefully measuring oils and lye solution with exacting accuracy. This precision isn't just for consistency, it's crucial for safety and quality. Too much lye creates a harsh soap that irritates skin, while too little leaves excess oils, resulting in a soft bar that cleans poorly. What makes this process fascinating is the chemical transformation that unfolds. After combining oils and lye, soap makers stir continuously until reaching trace, the magical moment when the mixture begins to thicken and can hold patterns on its surface. Think of it like making pudding. There's a distinct moment when it starts to set. This is when artisans add their creative elements, fragrances, colorants, and additives like exfoliants or herbs before pouring into molds. Unlike hot process soap, which requires external heat, cold process soap generates its own heat through an exothermic reaction. After 2 to 4 days of hardening, the soap is removed from molds, but the transformation is far from complete. The bars must cure for 4 to 6 weeks, during which excess water evaporates, creating harder, longer-lasting soap. Simultaneously, the pH level decreases, resulting in a milder product that's gentle on skin. This patient approach to soap making allows artisans to create unique, handcrafted products with properties tailored to different skin types and preferences. The complete control over ingredients results in truly personalized creations, a craft that continues to thrive alongside modern industrial production, cherished by those who value both tradition and customization in their cleansing routine. Today's commercial soap production has evolved significantly from early methods. Large manufacturers use continuous processes where ingredients flow through a series of reactors and processing equipment. This industrialization allows for massive production volumes meeting global demand. Commercial soaps often undergo additional processing steps like milling, grinding and reforming the soap multiple times to create a more uniform product. Manufacturers frequently remove the naturally occurring glycerin, a valuable byproduct with moisturizing properties, to sell separately in cosmetics and other applications. Many commercial soaps aren't technically soap at all. Products labeled as beauty bars, cleansing bars, or body wash are often synthetic detergents. While these can clean effectively, they have a different chemical composition than traditional soap. The soap market has diversified dramatically, with specialty soaps catering to various needs. Transparent soaps achieve their clarity through the addition of sugar, alcohol, and glycerin, creating a distinctive appearance many find appealing. Liquid soaps use potassium hydroxide instead of sodium hydroxide, resulting in a softer consistency that can be bottled. This innovation revolutionized hand-washing habits worldwide. Luxury artisanal soaps often feature exotic oils like argan, camellia, or babassu, along with botanical extracts, clays, and even gold flakes for a premium experience. Sustainable and eco-friendly soaps represent the newest frontier, with manufacturers exploring biodegradable packaging, palm oil-free formulations, and carbon-neutral production methods to meet growing environmental concerns. Thank you for watching another episode of Everyday Nuggets. If you enjoyed this episode, please like and subscribe for more videos. If you have suggestions for other everyday objects you'd like to learn about, please leave them in the comments below. Stay clean and stay curious.